All right, welcome. My name is Ryan Hoger with Temperature Equipment Corporation. This is one of our many webinars that we've done at this point. There's literally thousands of hours of recorded webinars on our website if you're interested. This week's topic is the IECC 2015 with a specific focus on HVAC systems. So we're not going to talk about envelope or lighting, and heck, we're not even going to talk about other mechanical systems that are not HVAC. So we're not going to talk about service water heating or any of that right now. Just HVAC focus. It's enough for a 1 hour webinar or more. This is the first of 3 parts coming up over the next 3 weeks. So this one's kind of a general one, but next week is a specific focus on control systems. And the week after that is a focus on rooftop compliance with the new code. There's a lot going on there. So let's dive in. As you guys have questions, type them in the chat box or the question box, whatever it's labeled over there in the bottom right-hand corner of your screen. And I'll glance at that every once in a while and take a look at it. For you guys that need PDH hours in Illinois and Wisconsin or other states, if you're claiming them in other states, in order to get those hours, you needed to have said yes to the question when you registered that you needed the hours. You needed the certificate for PDH. And then there'll be 5 questions that pop up during this webinar throughout the course of the webinar that you need to answer. I believe you got to get 3 of the 5 correct. They're not really hard. If you're paying attention and heard whatever I said 3 minutes earlier, you should get the question right. But it's just our way to prove to the state that people actually were online and involved, if you will, since it's not a real classroom type thing and we can't see you there. All right, so let's keep going. So there's a lot of regulations going on with HVAC, as you're probably aware. We dump those into 3 main buckets in our world over here. One bucket is environmental regulations. That's typically EPA type stuff, oftentimes having to do with refrigerant. That affects what equipment selections we can use on projects. You probably all heard that, well, obviously, you know, R22 is pretty much gone, right? But R410A, R123, and R134A are all on the chopping block as well. So a bunch of new refrigerants are going to come down the pipe, and you're going to have to learn how to deal with all that. But that's not today's topic. We also have tons of energy efficiency standards. Most of that comes out of the Department of Energy. We'll touch on a couple of those today, just as they relate to the codes, just so you know. But for the most part, we're not going to focus on DOE standards either. The Department of Energy standards typically are enforced at the manufacturing level and occasionally the distribution level, but typically the manufacturing level. For today, we're going to focus on the energy codes, which is part of the building code discussion, and that is enforced by the local entities, which is typically states, counties, or city governments, and the people that are involved in that typically are the design professionals for that specific building or home. All right, so that's what we're going to stick on. As you probably know, IECC is written by the International Code Council. About 20 years ago, the 3 regional groups in the United States got together and said, hey, it's kind of stupid that we're all writing our own standards and then people got to try to follow 3 different standards, you know, all over the country. Let's get together and just make one entity and have one document that comes out. So that is what happens now. They publish many documents, mechanical code, fuel gas code, etc., fire codes. For today's purposes, we're going to talk about the energy code only. We're going to talk about both residential and commercial. The book has both in the same book. That's very different from what you guys are used to that follow ASHRAE type stuff, where you get separate books for separate projects. Here it's one book for residential and commercial. However, it's really kind of like 2 books in one, because the first half of the book is one, the second half of the book is the other. There'll be some references to ASHRAE 90.1 in the IECC. We'll talk about that when the time comes, generally on the commercial side. And the IECC book gets published every 3 years. So the most current one is the 2018. None of you guys on this call, I believe, are following that code yet. Almost everybody on this call, by the way, is from Illinois and Wisconsin, which makes sense because I live right between the 2. So that's what most of you guys are following is the 2015 code. But 18 is already published. If you want to take a look at it, you certainly can. The IECC codes come out typically 18 months after the equivalent ASHRAE standards come out. That's because IECC doesn't really have a research arm. It's mostly building code officials that are on those committees, and there's some manufacturers and other folks too. Whereas 90.1 has a lot of research going on with it, so the code folks tend to, I don't want to say cut and paste out of 90.1, but they tend to take a lot of that information and put it into the energy code book, and then they tweak stuff, right? And things they usually tweak are things that are either ones that they don't believe are cost effective that an ASHRAE does, or they're ones that the building officials think are going to be very difficult to inspect and police. So they might take those out for those kind of reasons. So more locally in the Midwest, and I think 97% of you guys were from Wisconsin and Illinois. So we're going to focus on those two things specifically. Wisconsin's the exciting thing right now, as many of you probably know. Earlier this month, the IECC 2015 went live for the state of Wisconsin. Both the commercial and residential provisions of the book were adopted. However, for you guys familiar with Wisconsin, many projects residentially follow the Uniform Dwelling Code, and they do not follow this code, so they're kind of in their own bucket. I had one individual type in that there's an audio problem cutting in and out. If you guys are all having that issue, let me know, and I'll try to figure out what's happening. But if it's just one or two people, then it's probably on their end. Anybody else having an audio issue? Just two guys. Well, crap, it's a lot of guys. Okay. Give me 20 seconds to try to make some quick adjustments here and see if we can make it a little bit better. Can you guys hear me now? Is that better? Okay. All right. Sounds like we're in good shape, right? If we're in good shape, keep typing yes on this. I know we're good. I switched from my computer microphone to my cell phone, so hopefully that helps you guys with the audio. We're good on audio? Yes. Dude, you guys are killing me. You guys said that's worse. All right. I'm gonna go back to the computer and we're just gonna have to roll with it. Going back to the microphone, let's do it that way. I do apologize for that. I'll talk louder and I'll talk slower. And you guys that know me, the slower is going to be really hard for me to do. But we'll try to do it that way. All right. So Wisconsin is following the new code. If you have a commercial building or residential occupancy in a commercial building, you'd be following the IECC. If you have a true residential building, you're still on the 2009 version. Illinois, we're following residential and commercial for all projects. There's a few exceptions for some special institutional type situations, but generally speaking, all your commercial and all your residential in Illinois are following the new code. And in Michigan, it's just the residential stuff, not the commercial yet. In Wisconsin, when you go to the state website, you look at the commercial building code, that's what we're looking at today. Up above that is the uniform dwelling code. That's where you would go if you had residential, true residential, like single family, or very small multifamily, like, duplex and townhouse type stuff. You guys that do work in Wisconsin know how to define the two typically. Once we're in the commercial building code, we're looking at the section called energy conservation. That's what we're going to focus on today. So I'm going to go through some of the major things on the IECC. First, we'll do residential for about 10 minutes, and then we'll do commercial the rest of the time. And as specific amendments come up in relation to Illinois and Wisconsin, I'm going to tell you what those amendments are, so you know how they differ from the true IECC code. Right? In Illinois, if you want to get the amendments, there's that link down at the bottom of the page there. You don't have to write that link down if you don't want to. I will post it on the chat thing here in a little bit, so people can just do it that way. At the end of the webinar, I'll post these links on here. Someone try to remind me if you could, or you can email me later instead of writing them down. Same kind of deal with Wisconsin. post that link right there for you guys, so you don't have to try to do it. All right, as far as energy code goes residentially, there's been some pretty big improvements over recent revisions. However, the 2015 revision for IECC residentially was not very much. It was less than 1% more strict than the old one. So essentially 2015 is very similar to the 2012 document. So we'll go through that pretty quick because it's very minor. These are the states that are following the 2015 from a residential standpoint. Wisconsin obviously is not dark blue yet because their true single family is not on it. But Illinois and Michigan are. Commercially, same kind of deal. It's been getting pretty strict. However, the last jump from 2012 to 2015 was less than a 9% improvement. So it's a pretty good improvement. Most of the stuff in the 2015 is the same as 2012. However, a lot of the changes that have happened have really affected packaged rooftop units. And because packaged rooftop units are more than 50% of the market, that has made a pretty substantial jump, 8-9%, in the overall savings of the whole document. And in this case, on the commercial map, Wisconsin should be shaded dark blue, and it will be eventually. This map just has not been updated yet. So we are now up to 13 states commercially following this new code. So when does the code apply? Residentially or commercially? Obviously applies to new construction. I don't think there's any debate on that. Everybody gets that part of it. The other discussion is, well, what if I have an existing building? So the 2015 document is much different than the 2012 and prior versions. There's now a separate section for existing buildings. And you can go in and read what applies to an existing building and what doesn't. And you might see some stuff out there saying, oh yeah, you don't have to do a bunch of stuff. It's so much easier, blah, blah, blah. Well, the fact of the matter is the stuff you don't have to do is not related to HVAC. There's a bunch of exceptions for windows and roofing and stuff like that. When it comes to HVAC, you're pretty much doing everything you would do on a new construction project. So if you add an addition to a building, it says go follow section C403. Like, oh, okay, that sounds easy. And you go look at C403 and you realize that is the entire mechanical section. So you got to do everything. There's no outs there, right? If you have an alteration, right, you change out a rooftop unit or something like that, or you want, instead of one boiler, now you want to have two smaller boilers, whatever you're thinking about there. Alteration, it says follow section C403. Do everything in the code book essentially, right? And they even made a point to point out economizers, because some guys were saying in past versions, oh, I only changed the rooftop and the old one didn't have an economizer, so hence the new one doesn't. No, the new one requires the economizer as well. They specifically pointed it out just to make it more obvious. But the general rule of discussion is only the thing you touch has to be brought up to code. So if you go replace rooftop number 3 has got to be brought up to code. But rooftops 1, 2, and 4, you don't have to do anything with those, right? That kind of idea. That's kind of the deal with that. All right, so let's have our first quiz question just to make sure you guys are alive and make sure you guys get your credits. If you guys don't need PDHs, you don't have to answer, but you're certainly welcome to. It doesn't hurt. All right, so first question. What is the commercial energy code in the states of Wisconsin and in Illinois? You should have 5 choices popping up. There we go. Your choices are A, 90.1 2015, B, 90.1 2016, C, IECC 2015, D, 2009, E, 2018. For you guys that are answering on the question chat box, do not answer there if you need PDHs. You have to answer on the poll thing that pops up. That'll track your answers, and they'll be able to be graded by them later. Jorge asks, or George, I'm not sure how you pronounce it, if the 2015 code is applicable to industrial applications in Illinois or Wisconsin. Generally speaking, yes. However, those get dicey, and you'll want to look at them on a case-by-case basis because there'll be lots of things you don't necessarily have to do. You might have an office area attached to a manufacturing plant, and the office area will have to comply, but the other part may or may not. So there are things like that that'll come up. So you'll want to look at those on a case-by-case basis. Some portions of the building may have to do it, other portions maybe not. Just depends on what it is. All right. Looks like most of you guys have responded. 80% of you guys answered. I'm going to close the poll in 5, 4, 3, 2, 1. And it looks like most of you guys got the answer correct, which is 95% of you said IECC 2015. All right, moving on. All right, let's talk about some of the residential provisions specifically. So the first thing is, you'll see in the code book, some sections will say, like in this case, controls, parentheses, mandatory. Other ones may say something in parentheses called prescriptive. Mandatory means you need to do it. Prescriptive means you probably need to do it. But there are ways around that, and we'll talk about the ways around it. Right now, we're on mandatory stuff. You got to have programmable thermostat. That's been in the code for a very long time. That's nothing new at all. It's got to be a schedule. It's got to be a programmable thermostat with schedules. I'll say it that way. Interestingly, they require the thermostat to start out with initial set points of 70 or lower for heat and 78 or higher for cooling. I don't know why they've codified that, because the building owner is going to do whatever they want later anyway. But that's technically what you got to start out with. There's some requirements for heat pumps to make sure that you're using the compressor heat pump instead of your electric resistance heat when the compressor is able to handle the load, right? And that's nothing new either. Boilers have to have outdoor temperature setback. That shouldn't be anything new either, because the DOE rules since 2012 require that anyway. Every residential boiler in the entire country, irregardless of state codes, has to have some type of automatic means of water temperature adjustment, which generally means outdoor air reset. And you have to have controls for snow melt systems, so they're only running when it's cold outside and you have precipitation. Really, the only big change on here from the 2012 version is that there used to be an exception for radiant floor systems to not have to use a programmable stat. The radiant floor system has a 6-hour, 8-hour lag time, so a programmable stat doesn't make sense. That exception is gone, so technically you have to have a programmable stat even on a radiant floor, although I would argue it doesn't make sense, but that's the way the code's written. Ductwork residentially, ductwork has to be sealed and it has to be insulated. Insulation for both supply and returns needs to be R8 in the attics, R6 in the crawl spaces. The big change there from the previous version of the code is that it used to be only R8 or R6 in the attic. Now it's up to R8. That's a big deal, but that is a change. Sealing is mandatory. You have to do duct sealing, and it tells you have to do it per the IRC or IMC, whichever you're following for your type of project, commercial or residential. You have to do that sealing, but then additionally, you have to do duct testing. So 2012 had this as well. So you guys in Illinois, this is nothing new. You guys in other locations, it might be new to you because some of you guys have skipped, like Wisconsin, skipping the 2012 completely. So if the ductwork is newly installed, new construction or in a retrofit situation, new ductwork, the ductwork would need to be leak tested, pressure tested with a duct blaster. There's an exception to that. If you can keep all of your ductwork 100% inside the conditioned thermal envelope, you do not have to do the duct blast test. Right? So, but as soon as you put 5-foot run up into the attic or through the crawl space or an exterior wall or something like that, as soon as you do that, then immediately the duct testing requirement comes in. And you have to not only seal the duct and test it, but get it down to a certain leakage level. That level is 4 CFM per 100 square foot of home. If you have your air handler installed, your furnace installed. If you do not have a furnace installed yet, then you'd have to have 3 CFM per 100 square foot home. So to make life easy on myself, if I had a 2,000 square foot home, I would be allowed 80 CFM maximum leakage if my air handler's in. Bronson types in a question: is AeroSeal report accepted by code for leakage testing? The leakage test report would be going to your local code official. I am not aware of any local code officials that are not accepting that report. Some of them may, some of them may not be. The code book itself does not specify what the report needs to look like. Some municipalities I know for sure, like Naperville, which is in the town next to me, I know for sure they accept the AeroSeal report. One of the residential dealers spent time with them 3-4 years ago, showing them how the system worked and how the reports looked and everything. The AeroSeal test is done at 25 pascals, just like this code test is. So it's essentially the same test. So there's no reason they shouldn't accept it and make you have a separate one. Nothing really changed in the 2012 to 2015 code. The whole section looks different for this duct testing, but when I read it over and over, which I've done a dozen times now, it looks like it's the exact same wording to me. It's just reorientated. No real big change from 2012 Todd asks if the exception applies to the actual mandatory ceiling. No. If I go back to the ceiling is required no matter what. You have to do the duct sealing. You only have to prove you did a good job of the duct sealing if your ductwork goes outside the thermal envelope. Otherwise, it'd be a visual inspection. All right, residentially also, you have to have load calculations for the systems that you're installing. The load calculations have to be ACCA Manual J or other approved calculation method. Other approved means your local jurisdiction says, oh, you don't have to do ACCA J, you can do this ASHRAE method instead, or whatever they else would approve. For most of us, it means ACCA Manual J. In addition to ACCA Manual J, you have to do ACCA Manual S. J is the load calc, Manual S is the system sizing and selection. So once I have the load calc and it says how many heating and cooling BTUs I need, I then have to use Manual S to make sure I size equipment in accordance with those load calcs. That means I have to do both the latent and sensible, cover both of those needs for the cooling system, not just one or not just the total. And it means I can't oversize the cooling system by any more than 15%. That's the maximum oversizing allowed. The code also specifies the indoor temperatures that I must design for. I can design for no higher than 72 on the heating side and no lower than 75 on the cooling side. So you're not legally allowed to size a cooling air conditioner for a 72-degree indoor temperature. That's not allowed. 75 would be the lowest you'd be allowed to do. One other big change to this section, which seems kind of quirky, is that they added this language in here at the bottom of 403.7 that you have to install equipment that meets the efficiency rating of the minimum federal law. Prior to that, it didn't say that. So what that meant is if I could get my hands on a 10-SEER air conditioner, I could install it residentially. There's nothing in the energy code that said I had to have a certain efficiency of equipment. Kind of weird. So now the language is in there. So if in inventory I have a 10-SEER air conditioner, I cannot legally install that air conditioner in a place that's following this code. Right? So they've kind of tied up that little loophole there. ACCA Manual J also specifies the outdoor conditions that I have to use. So I'm looking in Chicago at O'Hare Airport, just as an example. For heating, I can design for 2 degrees outside and for cooling 89. I cannot use the traditional 95 and minus 10. That's not allowed. I'd have to use 89 and 2. And if you look at, the bin profile of that, there's not really that many days of the year where it's above 90 anyway. It happens, but it's not very common. And the same thing on the low end. There's not too many days when it's below 0 outside. If I was looking at the Wisconsin data and I picked Milwaukee, because most of the guys on this call happen to be from the Milwaukee area, my temperatures would be 2 for heating and 87 for cooling. However, you are not going to use the ACCA Manual J for energy code compliance if you're in Wisconsin. There is a Wisconsin amendment to the energy code that says you have to use this table instead. That means if you were in Milwaukee, it'd be instead of, 2 degrees and 87, it's instead minus 10 and 89. So that's what you have to use in Milwaukee. You do not follow the ACCA tables in Wisconsin, you follow this amendment. But once again, if I look at those temperatures outside that range, it's very, very few days, very few hours of the year even, that I'm going to have anything outside that range. So there's no reason to size for like a 95-degree day or anything crazy like that. All right, last thing on residential, there are several other requirements. I will point a couple of them out here. One, you cannot use the building cavity as a ducting system. That used to be fairly common. You would use a return duct, you put some panning on the bottom of your joist to your basement, and that would be the bottom of your 4-sided duct, if you will. 2x4s would be the sides, and the plywood on top would be the top. That's not allowed anymore. You have to have a fully ducted system. You cannot use wall cavities or ceiling areas as your ducting means, right? So you can't use any building cavities, drywall, wood your ductwork cannot be made out of those things. There's requirements for insulating pipe systems, right? And then after that, we're kind of really done with residential HVAC. There's other stuff on this page that applies to mechanical systems, but not really HVAC. Everything else on here would apply to domestic hot water, which is a whole separate discussion, if you will. All right, let's get quiz question number 2 up there for you guys that need PDH hours or for you guys that just want to do it. True or false? Residential duct sealing is mandatory per IECC 2015. While you guys are answering that, I'm going to scan through and see if you guys wrote any other questions in for me. There's none right now. If you have questions for me, type them in the question chat box down in the bottom right-hand side. We'll give this 20 seconds for you guys to answer, and then we'll keep moving along here. It's like 72% of you guys voted, so I'm going to close this. If you don't need to vote, that's fine, but if you need the hours, credit hours, then please vote or answer. I'm going to close it in 5, 4, 3, 2, 1. So the correct answer is true. This is required per the IECC 2015. Oh, I lied. There was a couple other residential things we needed to touch on. This one, because it's kind of weird, because it's not really energy related, but it's in the energy code. You are required per the IECC 2015 to have a mechanical ventilation system, and it is mandatory. You are not allowed to have operable windows for your ventilation. It has to be a mechanical ventilation system. In addition to that, having a mechanical system, bring all your fresh air in from outside, the system has to meet the minimum efficiency requirements in that table below. And you look at that below and you're like, range hoods, bathroom fans, like who's using that for ventilation? That's kind of weird, right? You're probably using your furnace or an ERV. Well, if you're using your furnace or ERV for your ventilation system, then that table doesn't apply to you. Instead, you have to have an ECM motor. If your equipment is tested and listed equipment, and that's being used for ventilation, it has to have an ECM motor. ERV is tested and listed per, HRI. So that would have to have an ECM in it. You cannot put in a regular ERV with a PSC blower. If you're going to run an outside air duct to the return of your furnace and use your furnace fan to distribute the ventilation air around the building, your furnace fan has now become the mechanical ventilation fan. So it would therefore need an ECM motor. So if you're going to comply with mechanical ventilation by using your furnace, you need to have an ECM, not a PSC blower. This is going to become very easy to comply with very soon, because some of you might have heard there's a Department of Energy rule that was been published. It goes into effect in 13 months. That'll essentially make an ECM motor the bare legal minimum thing that you could buy. There's a new thing called Fan Energy Rating, FER, that'll specify the minimum efficiency of motors and fans for residential equipment like furnaces. And because of that, a standard PSC motor will not be able to comply. And the manufacturers, I presume, will use ECMs, or they'll invent some new technology. So probably ECM. So that's going to kind of go away on its own. Additionally, Illinois amendment for mechanical ventilation, instead of leaving it up to the designer to choose ASHRAE 62.2 or IRC or whatever for ventilation, Illinois put the table right into the amendment document. So it's based on the square footage of the home and the number of bedrooms. So if you had a 2,000 square foot home with 3 bedrooms, you would need 60 CFM of outside air. If you had a 3,500 square foot home with 5 bedrooms, you would need 90 CFM of outside air. The thing I want to point out about this is these numbers, 60 and 90 and everything else in this table, that's if the ventilation system is running 24/7, nonstop. If you want to cycle the fan, then you have to look at the table down below and apply these factors. So if you want to run the fan only 30 minutes out of each hour, you need to double the numbers. So 60 becomes 120, 90 becomes 180 in my 2 examples. If you want to run the fan 15 minutes out of the hour, you need to quadruple the numbers. So 60 becomes 240, 90 becomes 360, right? So you're probably better off running 24/7. Otherwise, you get too high of air coming into the inlet of the furnace heat exchanger. Kitchens need either intermittent or continuous exhaust fans. That doesn't usually apply to HVAC, but some of you guys do that work. Same deal with bathrooms. They either need a fan on a switch doing 50 CFM, or they need a constant 20 CFM. Typically, if you're running an ERV, you're going to pull that 20 CFM. There are a few other amendments in Illinois. For the most part, the quick summary on that is no matter what you do, on new construction, you got to do everything. On equipment changeouts, you're going to have to do the programmable stat. You're going to have to add the boiler controls on there. You're going to have to insulate and seal any new ductwork that you have. And you're going to have to do mechanical ventilation. What you don't have to do is you don't have to do the pressure testing when you seal the duct. It wouldn't be fair to make you pressure test 10 feet of new duct on the entire system when you didn't install the entire system. And then it just completely ignores a few other things. So presumably you don't have to do them, like pipe insulation on a retrofit or load calc on a retrofit, although you probably should. All right, question number 3, and then we're going commercial here. Which of the following residential projects would require mechanical ventilation per IECC 2015? A, new construction home. B, furnace repair. C, addition or home renovation. D, A and C, both. E, B and C, both. So hardly anybody voted. Is it too hard of a question? You guys can't see the question, Michael says, but people are answering. So did it come up now, Michael? Russell says the slide is stuck on 2019 DOE. Let me switch back. How's that? Can you guys see the slides again now? Does it say quiz question number 3? There we go. Now a bunch of people are voting. That was weird. I just had to stop presenting my PowerPoint and then re-present and everything was fine. It's 2 weird things I've had with this presentation. Out of hundreds of webinars, I usually have no problem. Today's a little weird, quirky one. All right, I'm going to give you guys another 20 seconds to answer. Looks like most of you guys are getting the right answer. All right, I'm closing it in 5, 4, 3, 2, 1. The correct answer is D. You would not have to do this on a furnace repair, like if you were just gonna, change a gas valve or something like that. Only on the major stuff like new construction, additions, renovations, replacement of equipment, and so forth. All right, commercial stuff. First thing we need to know on the commercial side is that per the IECC book, there are 3 different ways you can choose to comply with the code. You can pick any one of these 3 ways, but you cannot mix and match them. The normal way is actually number 2, which basically says crack open your book and do everything in the book, right? Whatever it says in the book for mandatory and prescriptive, do both of those things, right? You can do that. Option number 1 would be take your code book and toss it in the trash, pull out your ASHRAE 90.1 2013 book, and do everything it says in that book instead. You can do that. So 90.1 is an approved compliance path, commercially speaking, for IECC 2015. The third method would be, well, I don't want to use ASHRAE, but I can't really do the prescriptive thing because I have some weird quirky things going on that don't work well with prescriptive. For example, if you have a VRF project, how the heck are you going to do the economizers, right? So in that case, you can use option number 3, which says you need to energy model the whole project, see how much energy it would use, then energy model, as if you built it to code. Then energy model it the way you want to build it. And if the way you're going to build it saves 15% more energy than the way the code book had it, then you can do it your way, right? In Wisconsin, there's an amendment to that, and you do not have to do 15% better. You just got to meet the code. So you energy model it per the code, and energy model it the way you want to do it. And if you are equal or better efficiency, you're good in Wisconsin. In Illinois, you got to beat it by 15%. Always still have to do the mandatory provisions, whether you're in section number 2 or 3 on this page here, you still have to do the mandatory stuff. It's the prescriptive stuff that you could trade off. So maybe you can't do the VRF job with economizers because economizers don't work well in that application. So all that energy you would have saved with the economizer, you're going to end up having to make it up with better efficiency on the heating and cooling plant or better windows or whatever it is. All right, some of the specifics. Just like residential, on the commercial side, we have to do load calculations. You have to do them per the ASHRAE standard 183, which is not a big deal. Most of you guys know how to do that anyway. You have to use the same type of interior design temps, which means a maximum of 72 heating, a minimum of 75 cooling. That lines up. Then in regards to equipment sizing, instead of using ACA, which is only for residential, the code spells it out here, you cannot size the system any bigger than your loads. So if your load says you need a 10-ton air conditioner, you cannot put in a 12.5. You can only put a 10. You can't even put a 10.1 in. However, if you have a package system with both heating and cooling, such as a rooftop unit, you are allowed to go a little bit bigger on either the heating or cooling in order to get enough BTUs on the other end of the scale. They recognize the fact that those are package systems. You can't dial in the exact heating and cooling, so you can upsize one or the other in order to make sure you get the minimum heating and cooling covered on the other side of the fence. Outdoor air temperatures come into play there as well. If we look at the ASHRAE handbook, if I look for Chicago, it's -1 for heating, and then either 88 or 91 for cooling, depending on which column you want to use. The code does not force you into one column or the other. In fact, it doesn't even force you to use the ASHRAE handbook tables. You could use you can use other weather data sources if you want, but you have to cite some cognizant weather source. Wisconsin, if you guys are at Milwaukee, which would be Mitchell, -1, and then on the heating side, and 89 or 86 on the cooling side. However, once again, for Wisconsin, there's a special amendment. So you ignore the ASHRAE numbers and you use the amendment, which means in Milwaukee, it's -10 heating, 89 cooling. Right? So if you're using typical software tools, you will need to stop using the defaults of the geographic locator on your software and instead dial in these numbers. On the indoor side, Wisconsin has amendment commercially as well. Certain spaces do not have to do the 72 and 75. And if you look at the list of spaces down the right-hand side, they're ones that make sense. They're typically industrial type things and specialty areas. So you might not have to do the normal. You might have a different minimum heating temperature in those cases. You saw this chart before, but it comes into play again over here. Equipment historically, as you know, has had an EER rating, energy efficiency ratio. That is, how efficient is this equipment on a 95-degree day outside with 80, 67 return air conditions, right? Something that probably doesn't happen in most places of the country. I don't really care how efficient this unit is on a 95-degree day. That day hardly ever happens. How efficient are you on an 85-degree day or 75-degree day? Tell me that, right? Same thing if I'm looking at Milwaukee, same kind of discussion. I don't care about a 95-degree day. How efficient are you on these other days, 60 to 90 degrees, if you will? I don't really care much below that because then I'm probably in economizer mode. So how efficient are you on these days? Because of that, EER is being replaced with IEER, Integrated Energy Efficiency Ratio. So what happens there is that they do the EER test at 100% capacity on a 95-degree day. Then they do another test on a partly loaded 75%, 50%, and 25%. And they take those and they weight them. So the 100% only gets a 2% weighting per the formula on top. The 75% testing point gets a 62% weighted bucket. 50% gets a 24, and then 12% on the really low end. So essentially, they're telling you 100% capacity, that efficiency is irrelevant. You need to focus on the mid-tier ranges, 50, 75, and those kind of things. In the IECC, if you look at the tables, there's, I don't even know, 10 pages or so of tables on there. This is just one of those pages, and this is the one that deals with split system AC and package rooftop AC. So small stuff, under 5 tons and under, needs to be 14 SEER. You can still buy 13 SEER. That's an existing thing in the marketplace that distributors have, but you cannot legally install that in states that follow IECC 2015. So you cannot install it in Wisconsin or Illinois. And then for the bigger stuff, we go to that IEER. Now, right now, there's still an EER and IEER requirement. The EERs did not change from 2012 book. The IEERs went up significantly. Right? So they're basically telling you through the code, they're telling you full load is not very important, part load matters most. Right, so let's give you an example of a few of those there. And then this just keeps going on for different types of systems, and then for heat pumps, and then for boilers and chillers and so forth. Economizers are required, as you probably know. Most of you guys know what an economizer is, so we can kind of skip over how that works. We'll talk about that more in 2 weeks on a different webinar. But an economizer is required when you have 54,000 BTUs of cooling and larger. There are some exceptions to that. Someone said no question, can't see. Lost audio. Dang, this is killing me, man. Again. I don't know why that keeps happening. Can you guys hear me again? Or are we still bad? All right, most people are saying it's pretty good now. As long as I keep close to the mic, which I will definitely try to do. My back will kill me later. So 54,000 BTUs, which is 5 tons and over, needs to have an economizer on it. There are some exceptions, like exception number 3 for certain process applications, exception 4 for some residential spaces in high-rise buildings with chiller systems, exception number 5 be like a little church, like a little one-room church where you're only using it Sunday morning and Wednesday night, and that's it. So it's less than 20 hours per week, so you don't have to do the economizer, chilled beam type stuff. There's a few exceptions like that. But for your normal retail, office, school type stuff, you're going to have to do the economizer. In Wisconsin, there's an amendment to that. It's still the 54,000 BTUs for most systems. However, packaged rooftops, it's all packaged rooftops. So that would also then include 4-ton, 3-ton, 2-ton type units that you have to do the economizer for in Wisconsin per the amendment. This map's going to come up on the economizers and ERVs and a few other things, so I'm going to show it to you right now. For you guys in Northern Illinois, you are in Climate Zone 5A. For guys in Southern Wisconsin, you are in Climate Zone 6A, at least right now. The next version of the code, this map will change, but for 2015, this is our map. Taylor's asking about fault detection and diagnostic on economizers. We will get to that here in a second. Once you do have an economizer, like Climate Zone 5A and 6A, as you can see, require economizers. The economizer, if I have a dry bulb control, I got to set it for 70 degrees. I can no longer set it for 55 like we used to do 20 years ago when I started working here. I can't even set it for 62, which is my favorite number to set it for. I got to set it for 70 degrees. If I have an enthalpy economizer, I need to set it for 28 BTUs per pound of dry air. No one knows what that means, right? Probably not. And 75 degree cutoff. We will show you on a site chart what that means. And if you have differential enthalpy, then, well, it's pretty straightforward. If the return air is worse than the outside air, take the outside air. So 70 for dry bulb, 75 and 28 for enthalpy. If I was to graph those out, that little black line is my old 55 degree set point on my psychrometric chart. Now I move all the way over to the yellow line. All right, so it's a lot more days that I'm going to need to have an economizer operating. So a lot more energy savings. I'm going to graph the enthalpy out, 28. That's those little tiny numbers off to the left hand side of the chart. I graph down that 28 there. Now, anything below the 28 and to the left of the 75 degree number becomes an economizer day. To the right of that or above that is a non-economizer day. Additionally, the code requires an integrated economizer. This is not hard to do because every economizer controller can do it. However, in order to do it, you must have a 2-stage cooling thermostat. Even if you only have 1 stage of compression, you still have to have a 2-stage stat and wire the 2nd stage up to the economizer in order for that to work correctly. But an integrated economizer is required. So what that means is, in summary, if it's above 75 degrees and 28 enthalpy, then I'm going to be in a compressor day. If it's below that, I'll be in an economizer day. And chances are, if it's between 55 and 75, I'll be in an integrated economizer day, which means I will have both compression and economizer working together. Paul asks, AC equipment IEER rating based on equipment. IER ratings are based on standard ratings. 80, 67, and 95 are actual design conditions. The ratings are based on 80, 67 return air, meaning 80 dry bulb, 67 wet bulb, and 95 degree outside air. It has nothing to do with the actual conditions at your property, right? Because the ratings are for the equipment itself with no idea where the equipment's going to eventually go to. John asks if a church in Illinois with a 3-ton system needs an economizer. It does not need an economizer at all. Actually, any 3-ton system in Illinois does not need an economizer. However, if your product was permitted under the old 2012 IECC, then instead of 54,000 BTUs, the number was 33,000 BTUs. So if you're permitted on the old code, you would have needed it. The new code, this is actually one of the few things on the new code where it's less restrictive. But at this point in Illinois, in Wilmette, where John's talking, you're 2 years into the new code. So Wilmette might be looking at the old code or something like that. Andy asks clarification on integrated economizer. This means 100% OA without refrigeration down to 55 degree dry. So here's the definition of what integrated economizer means. Unit shall have the mechanical cooling capacity to get down to 100%, with the damper 100% open, get down to the full cooling load. So if you're designing for 55 degrees, Andy, then your statement is true. You need to be able to get down to 55 degrees with the economizer itself. If your design for some reason was 58 degrees supply air, then I guess you'd only have to get down to that with the economizer. All right. Other things on economizers, obviously you got to find a way for the air to get back out of the building. That goes without saying. We'll talk more about that in 2 weeks. The economizer must be interlocked to the occupancy. If you didn't know it, your economizer also doubles as your ventilation intake. When that happens, every time the fan goes on a packaged rooftop unit, the damper goes open to ventilation position, even if the reason the fan is going on is because you have a heating or cooling call for setback in the middle of the night. So every rooftop you probably ever designed, installed, or serviced is opening up its ventilation damper in the middle of the night when there's no people there for no reason whatsoever. The energy code no longer allows you to do that. When the building's unoccupied, you need to shut the outside air damper. Now you can open it for economizer mode for free cooling if you want to, but you do not open it for ventilation mode. We'll talk more about that in 2 weeks as well. All outside air intakes and exhausts from the building will need to have a low leak damper on them, a motorized low leak damper. There's an exception to that. If the building is under 2 stories or the CFM is really low, you can use a gravity damper instead of a motorized low leak damper. Once you have a motorized damper, either because this section of the code requires it or because the economizer happens to be motorized anyway, as soon as you have a motorized damper, it must be low leak. And it tells you up there in the first paragraph, it's got to meet AMCA 500D certification for low leakage. What that means to you guys visually in the field is that the damper blades will have seals on the edges and on the ends, which is kind of expected, but also the gears for the economizer will no longer be in the airstream, they'll be on the outside of the airstream. Because when they're on the inside of the airstream, the problem is they can't be perfectly tight because they're gears and they have to move. So now the gears are on the outside of the airstream. So it's pretty visually easy to inspect that and see that. But you have to have low leak economizers, or some manufacturers might call them ultra low leak economizers. The other problem with economizers, and you guys have probably seen this in other classes that I've done, is that economizers historically don't work. Right? They work. The technology works, the concept works, but things get broken. People screw them shut, people jam them open to get temporary airflow through there. Linkage arms get loose and sloppy. The settings get programmed incorrectly or adjusted or manipulated. And there's quite a few studies out there, including the one on the screen. This one here showing 64% of economizers are not functioning correctly in the field. Right? And this is 500 rooftop units at 180 buildings. Right? And there's other ones like this. The Honeywell similar study showed 70% of economizers are not working correctly. And remember, Honeywell is the one controlling the economizers, and they're telling you that things are getting messed up in the field. Right? So because of that, some groups, such as Title 24 in California, and now ICC, on the 2015 IECC, have taken that into account. And you need a new thing called Economizer Fault Detection and Diagnostics, FDD. The whole description on what that means, I'm not going to read it to you, but essentially what that is the economizer controller itself has to babysit and police itself for these various types of problems. So it's got to track these temperatures and try to determine if things are out of whack, try to figure out if economizer damper is not shutting all the way or if it's not opening all the way, all those sorts of things. And the Honeywell Jade Economizer, like I'm showing in the bottom corner of the screen there, it does that. I believe the Belimo Zip Economizer does that. And then a lot of your DDC type guys can do it as well. The older economizer controllers would not do this. Right? So you need this economizer controller on there. That's pretty easy to qualify on. And a lot of your low leak economizers will probably give you this economizer controller anyway. The harder one is item number 6 on there. The unit shall be capable of reporting faults to a fault management application accessible by day-to-day operating or service personnel. Generally speaking, that means a building automation system. Some people have tried to argue, oh, the economizer controller itself has the alarm, so we're good. Well, first of all, the economizer controller is in the rooftop unit up on the roof. That is not accessible to day-to-day personnel. For you guys in Illinois, if you go to the state website, they made an official interpretation saying specifically the economizer controller in the rooftop unit does not count as meeting this requirement, right? I don't know if Wisconsin has a similar interpretation yet, but I would expect they would, as most states have. Or if you don't have a BAS, you don't got one, it's a 2 rooftop project and there's nothing like that there, you can then choose to enunciate your alarms on the zone thermostat itself. and that would count as well. That takes a very specialized thermostat, but not a very expensive thermostat. There was 3 thermostats that used to be able to do that. Now I think we're up to like 8 or 9 models. All right, regarding control stuff, I'm going to touch on a couple things, and then the rest of the control stuff we're going to save for next week. But just like with residential, you got to have programmable stats. In the case of a commercial project, they have to be 7-day programmable. You got to have at least a 5-degree deadband force between the heating and cooling. So if your heating set point is 70, you cannot have a cooling set point any lower than 75, right? That kind of thing. You can't have overlapping heating and cooling set points. Brian asked if there's a list of T-stats that meet the FDD requirements. Yes, I do have a list, Brian. If you want to send me an email, my email will be on the last slide today. Send me an email and I can send you that list for you guys that want that. Or you can actually look on the state website. It's on there. Illinois state website. It's on there as well. You have to have adaptive recovery or optimal start on there. That's where the thermostat starts before the scheduled time in order to get to the exact set points at the time that you asked for. That's required of all the thermostats and controls. You got to have the ventilation interlock like I talked about before. That's required. You got to have the ability to display the FDD alarm. That's a requirement, right? So there's quite a few things going on there in terms of controls. Whether you have thermostats or whether you have DDC controls, you have to do all of these. Demand control ventilation is also a requirement per the code. We'll dive more into that in 2 weeks. But if you don't know what DCV is, demand control ventilation, it's a way to lower the ventilation amount below the mechanical code's required minimum ventilation on times when the building is less occupied. Typically use a CO2 sensor to measure how occupied the building is and then cut back that ventilation when less people are there. With the idea being hardly any building is 100% fully occupied at all times. That's required by code in lots of applications. For the 2015 code, if your project, if your area, your space, has a density of people of more than 25 per 1,000 square feet, then you will need to do demand control ventilation. There's some exceptions if you have smaller systems and things like that. But if you got like a high school auditorium or a gymnasium, or if you got a movie theater or these kind of places, you're probably going to have to do demand control ventilation. For you guys in Wisconsin, Wisconsin made an amendment to that. Instead of 25 people per 1,000 square foot, it's 40 people per 1,000 square foot. And that keeps it in sync with the old Wisconsin code, which was the 2009 version. Right? So keep that in mind if you're in Wisconsin. It's 40 instead of 25. If you have enclosed parking garages, there's requirements for controlling the fans on those spaces as well to reduce energy usage. So if you got an enclosed parking garage like downtown Milwaukee or Chicago or something like that, start thinking about carbon monoxide sensors for regular vehicles and nitrogen dioxide sensors for diesel vehicles in order to use those to measure if there's lots of cars running or not lots of cars running and cut back the airflow. We'll talk more about that next week as well. You probably have seen this chart before. It comes out of a Pacific Northwest National Lab study published in 2013. And this particular chart is showing you various modes of runtime for packaged rooftop units. Red is how many hours they spent in heating. Blue is cooling. Green is economizer. Purple is integrated economizer. But then baby blue is nothing. No heating and no cooling of any type. It's just occupied hours with the fan running for code ventilation reasons. So as you can see, there's a lot of hours where we're just running the fan and not heating and cooling. So what that means is the code has kind of captured onto that and said, well, we can keep making you put in more efficient cooling systems. And more efficient heating is kind of hard on rooftops anyway, because how are you going to get a condensing rooftop? It's not impossible, but it's hard. So let's pick on the fans, right? That's the big energy user here. Let's pick on the fans. So that's what we've done. Say we. The IEC is weird. The way it's worded was an error. It was worded in such a way that section 403.4.1.1 fan air control was accidentally put under the hydronic and multi-zone HVAC section. So therefore, legally, it only applies to hydronic systems or multi-zone HVAC systems. That is corrected in the 2018 version. So that's no longer an issue going forward, but we're not on that version in either one of our states. We're on this version. So if you have a multi-zone system, like a VVT system or a VAV system, or you happen to have hydronic heating or cooling coils, in those cases, you need to put a 2-speed fan in. Right? We typically call that staged air volume. Typically what happens there is when you're in full cooling, you get 100% of your design CFM. When you're on stage 1, you get 2/3 of your design CFM. Or if you're in vent only mode, meaning no heating and no cooling, you get 2/3. Additionally, I showed you this one before, integrated economizer control, but I skipped bullet point 2 and 3. Saved it for now because I don't really feel it belongs in the economizer discussion. It's kind of a separate thing. It relates to economizers, but it's separate. So bullet point number 2, if you have a system that is 75,000 cooling BTUs or higher, which is more than 6 tons, then you must have 2 stages of compression. You cannot have a 1-stage unit. You must have 2 stages or more. Bullet number 3 is the one that gets debated a little bit. Other DX units that control space temperature by modulating airflow to the space, right? So that means if you have, once again, VAV or VVT systems where a thermostat on the wall, space temperature, is controlling the damper, airflow, then you must have either 3 or 4 stages of cooling, depending on how big your cooling system is. This one got debated quite a bit in Illinois. If you go to the Illinois frequently asked questions section on the website, you will see the interpretation that these systems need to have the 3 and 4 stages if you have the zone dampers on. Wisconsin does not have an interpretation like that yet, but most states do, so I would expect Wisconsin would follow suit. All right, question number 4 on our poll question. Let me launch that for you guys. For our quiz question, once again, if you need PDHs, please do the question. Which of the following are required on a typical 10-ton DX rooftop installation? All right, so A, 12.6 IEER, B, integrated economizer, C, fault detection and diagnostics, D, 2 stages of cooling, E, all of the above. If you guys have more questions, please do type them in and I will try my best to answer them. I'll give it another 15 seconds or so for you guys to answer. Right now, every single person has it correct, so apparently this was an easy question. So I'm going to close it in 5, 4, 3, 2, 1. All right, apparently that was the easiest question I ever had because 100% of you got the answer correct, and that has never happened before. That's crazy. But I'll take it. All right. Quiz question number 5. Knock this out right now. If a zoning system is applied to that previous 10-ton rooftop example, which of the following is also required as a minimum? 3 stages of cooling, staged air volume or variable air volume, demand control ventilation, both stages and variable volume, or stages and demand control ventilation. One's probably a little bit trickier. Yeah, apparently it was trickier. Most of you guys are getting it right, but a lot of people got it wrong. All right, I'm going to close this one in 5, 4, 3, 2, 1. The correct answer is option D, which would be both 3 stages of cooling and staged air volume or variable air volume. You do not necessarily have to have demand control ventilation, not because of the things we just mentioned. All right, that was our last quiz question. So you guys that have to go, you're good for your hours here because we're there. But for you guys that can hang out for 5 more minutes, I'm going to highlight a couple quick other things for you. Energy recovery ventilators, I won't explain how they work because most of you guys probably know at this point. If not, we have separate stuff to teach you how to do that. ERVs are very frequently required. The first requirement you got to pay attention to is you have to have 50% enthalpy recovery on your ERV if it's a code required ERV. That means you have to do both sensible and latent recovery. You cannot get 50% of the total if you're only doing the sensible recovery. That means you cannot use heat pipes. That means you cannot use hydronic wraparound coils. You cannot use metal fixed plates. You have to either use a enthalpy wheel or you have to use an enthalpy core. Those are the 2 types of ways you'd be able to comply with this. There's some exceptions for various types of spaces and climates, but those don't typically apply to most of us. There's a few that do, right? Number 8 would be one that would apply to like a multifamily, condo building or something like that. ERBs, when are they required? We are climate zone 5A and 6A for you guys in northern Illinois and in southern Wisconsin. For you guys in northern Wisconsin, you're climate zone 7, right? The old code, everything to the right of that yellow box, 30% and above, that's exactly the same. Nothing changed there. So if you have a 30% outside air system with 5,500 CFM on your supply fan, you would have had to do the economy or do the ERV. Now there's another bucket below that for 20% outside air, 16,000 CFM, and 10% outside air on a 26,000 CFM supply system. Additionally, there's now another table for systems that operate basically year-round. There's 8,760 hours in the year. If your system's designed to operate most of the year, 8,000 hours, in those cases there, for climate zones in Illinois and Wisconsin, anything more than 10% outside air, you have to have an ERV automatically. This is going to include a lot of your hospital-type projects and things like that. Technically, it would include like, I don't know, a 24/7 gas station or something like that. So that's when ERVs would be required. For hydronic systems, there are some requirements of noted interest that have changed from last year. The most interesting one is that boiler plants, if you have more than 1 million BTUs of heating in your boiler plant, you have to have a 3-to-1 turn-down ratio. That means you either need 3 boilers, each one of them doing 333,000 BTUs or whatever, or you need 1 boiler that modulates down to 33%, or I guess 2 that modulate down, right? And then as you get bigger plants, 5 million or 10 million BTUs, you need either more boilers or more modulation, right? So you can no longer take out a existing 1-stage boiler and put a 1-stage boiler back in. You'd have to put in multiple smaller modular boilers, or you'd have to have a large boiler that has good turn down. For you guys in Wisconsin, Wisconsin made an amendment to not follow this turn down requirement. So in Wisconsin, you do not have to do this. Illinois or other IECC states, you would have to have this turn down. You also have to have other stuff too for the hydronic plant. And this is not really a change from prior years, but you have to have isolation on the pumps, right? So you're not flowing chilled water through a chiller that's not even running, that kind of thing. Duct leakage, I'll spare you the statistics on how bad and how leaky ducts are. I'll just say they're bad. They're really, really bad. A lot of these systems are leaking 1/3 of their air into unconditioned spaces. It's very common for both supply systems as well as exhaust systems. Really, really bad, especially if they have shaft exhaust that's not fully ducted, right? So there are requirements in the code to resolve some of this and get some of these spaces to leak less duct leakage, which means I would have less fan energy involved and perhaps even less heating and cooling waste. So from a code perspective, just like residential, ducts have to be sealed, ducts have to be insulated. If the duct is in an unconditioned space, it's got to be R6. If it's outdoors, it's got to be R12. The climate zones that we care about, which are 5 and 6 for today's purposes. Additionally, the ductwork categories break into 3 categories: low pressure, which is 2 inches and under, medium pressure, 2 to 3 inches, and high pressure, 3 inches and above. And the code then dives in and specifically tells you how you have to seal those. The one of interest is high pressure right now. If you have a high pressure system, which is 3 inches of design duct static pressure or higher, you not only have to do the duct leakage like you do, or duct sealing like you do on all systems, you have to do a duct leakage test as well. So residentially, the duct leakage test requirement kicked in when you had ductwork in an unconditioned space. For commercial, the duct leakage test kicks in when you have a high static system. The higher the static, the higher the pressure, the higher the amount of CFM that will leak out of a given size hole. Other stuff, control requirements. We're going to go through these next week on the webinar if you're interested. We'll talk about what's required on BAV systems, water source heat pump projects, cooling tower controls, that kind of stuff. If you guys do DDC work or specified DDC work, probably would be interested in that. There are tons of tables of equipment efficiency, just like the one I showed you for split systems and rooftops. There's ones for all kinds of other systems. There are requirements for pipe insulation. I will note on that Wisconsin made an amendment to not update that portion of their code. Wisconsin's going to stick with the 2009 IECC levels. Illinois is on the 2015 levels of that book. There's requirements for fan efficiency. That's like a whole webinar in itself on all the rules on how much static you're allowed to have on your air handlers and that kind of stuff. There's tons of limits on hot gas bypass. You should try just in general to avoid having any hot gas bypass if you need it. There's a couple different sections of the code book you're gonna have to go back in and check out. We'll talk about that in the coming weeks on these webinars as well. Commissioning is required, balancing is required. Once again, Wisconsin has an amendment on that. You do not have to commission the systems if you're in Wisconsin per the code. You might still want to do it. It's still a good idea, but you're not forced into it. In Illinois, you are forced to do it. And then the last thing that I wanted to bring up is section C406, because it has caused tons of confusion in both the current and former versions of the code. For starters, if you're in Wisconsin, you can ignore this completely. Wisconsin made an amendment to just delete that section of the code and not apply. If you're in Illinois or any of the 12 other states that have IECC, you're going to have to do this in most applications. What this is, it basically says, hey, you did a great job. You did everything we said to do in the book. Now do one more thing for us. Pick one of these 6 things. In 2012, there was 3 on the list. Now there's 6 things to pick from. You can either make your HVAC more efficient, your equipment. You can make your lighting power density lower. You can add lighting controls. You can add renewable energy, right? You can do something with the surface water heating. Got some choices here. For you guys that do HVAC, if it's a chiller system and a boiler system, you could probably do item number 1 fairly easy and comply that way. If it's a rooftop project, you need to get the designer of the building, the architect, to completely avoid option number 1. There's no way to do it with rooftop units. You basically have to get 10% more efficient. Well, if you have an 80% minimum efficiency on rooftops, that means you now need an 88% gas heating efficiency. There's hardly any options to buy an 88% efficient gas heating rooftop. So it forces you out of a rooftop and into a boiler system. So unless they're prepared to have a boiler system with chilled water and all that good stuff, you probably are not going to be able to do this, right? Then you want to go the lighting route. Most products go the lighting route. We'll touch on this more next week as well. But as of the 1st of this year, there are new national requirements from the Department of Energy for the manufacturers of rooftop units to have fairly high IEERs. So what that means is they can't make any more low efficiency units. They can only make their mid-tier and high-tier efficiency units. If people still have them, they can still install them, assuming local code allows that, but they can't manufacture anything further. If you look at those requirements, the DOE 2018 column next to the 2015 code IECC column, they in fact are very similar. There's a slight difference there. At some sizes, I put 5, 10, and 15 ton examples on here. You can see the 10 ton, I need to get a 12.7 IER unit instead of a 12.6. But the purpose of showing it to you this way is that if you get a DOE 2018 compliant unit, you're pretty much going to automatically comply with the state. However, if you buy an Energy Star compliant unit, which you would think would be the best stuff out there, you will not comply with either one of these things, right? So the Energy Star spec is fairly outdated, and they're probably going to update that soon, I would think. All right, so that kind of wraps us up. As I mentioned, next week on Thursday, there is a webinar on the energy code as it relates to control systems, and we'll also talk about a few other codes that touch on some of these control systems and kind of talk about how they all tie in together. And then in 2 weeks from now, we'll put a big focus on rooftop compliance as related to IECC 2015. We talked about it a little bit today, but we're going to go into it a little bit deeper. So you can find those on our website if you go to tecmungo.com/training, and then you click on the online learning webinar section. You'll be able to register for those just like you registered for the one today. All right. Any further questions? I'm going to stick on here for a minute or two. I'm also going to real quick paste in a couple of those links that I promised you guys that I would paste in, because otherwise it'd be hard for you to get them. So move this to the side. Here's the Wisconsin link. I'm going to grab that, and I'm going to put it in this little chat box for you guys. So if you want that, click on that link, and it'll open up in your web browser, and then I will give you the one for the Illinois amendments as well, because they're so long, for you to write them down would just be a nightmare. All right, so there's the 2 links. They should be in your little chat box in the bottom corner, so you can readily find those pages and download the amendments to the code. I will also point out for you guys that are interested The code book, IECC 2015, is actually available for free on the iccsafe.org website. You can navigate on there and get to a free copy of it, or you can buy a copy. The free copy is one of those online things where you can only read one page at a time type of deal. If you buy it, you can buy either a paper book or you can buy a digital PDF that you could then search and so forth, and things like that. But there's a couple options there on getting the code book. What other questions? Looks like there's no other questions at the moment. If you do have other questions, just send me an email. My email is, in fact, up on the screen. So whatever you got, just send it to me, and I'll try my best to answer it. Otherwise, I'll hopefully see most of you guys next week. Thanks. Bye.